Hey everyone, we're going to do a quick thing with not just LM, but LM Rob. Now, as you can see here, we already did this poison mice, time, poison, first, second, third, etc. These were the results with the regular LM. We compare it to the first is the base, right? Second is here. That's the level of poison. And the third is here. So now remember, this isn't comparing third to the second. This is comparing third to the first, which is the base, because it begins A, B, C, D, E, F, whatever letter is first begins, so it goes first, second, third, not because it's the order first, second, and third, but because F becomes before S and then S becomes before T. So basically what we have here are three different levels of poison, and then we have time to see if there's a difference between these attributes. Poison is the variable, and then first, second, and third are the three attributes of this variable, just like gender would have two, male, female. As you remember, there was one outlier in this second, right? That's pushing this algorithm and the results up. So if you notice, the second one is not significant relative to this first, right? But they are different. It's just that this one outlier is pulling it up. Is that fair? Well, we're going to do something with robust regression. That eliminates often these outliers. An outlier is an extreme case. So take, for example, what use kids, something palatable for you, GPA. Let's say you bust your butt the whole entire time and you get all A's, and then one jerk teacher like me gives you an F, or here they say E. It hurts your whole entire GPA because that one brings it down. The same goes if we are getting an average of income, and then all of a sudden, Bill Gates or Beso, or we'll call him Boso because I still have oh no, I don't, Trump's tweets, as we already did. So how do you kind of take care of these outliers? In this case, there's only one, but there might be a few others here and stuff like that. An outlier, how do you measure it? It depends on, the algorithm. Like it'll say this is an outlier, obviously, because it's way up here, but there might be another down here, etc. It'll calculate what's quote unquote outside of the norm. So we do this with the Robustbase packages. You remember with packages, we install them, right? Watch out for installed. It should just say install. And I already have it, but we'll just put it in again. I don't think it'll do anything. This is Robustbase. This is a very conservative package, meaning it's not politically conservative. I don't know where Robustbase stands, but it's very difficult to get a good p-value often with this, or it really brings it up. It depends on where it moves, as we're going to see in this case, but it often causes when we remove the outliers, results to be not significant. Here, we're going to see something different. So you just install the package. Oops, this package is already installed, so that's probably why they're warning me, blah, blah, blah. Is already in use, but I'm just going through the motions. And then you go through library, Robustbase. Here you'll see it after you install it. Boom. So now we're going to see, all I have to do is flip up here with the arrow, and instead of poor mice LM, I'm going to do LM and then just put an R. And if you have it installed, you can see Robustbase here. I'm going to change just to poor mice, robust, or robust mice. So here we just, okay, now we're going to get the summary. So you see two, poor mice is regular LM, poor mice robust, for robust regression that kind of deals with these outliers. We're going to get another one. So what are we doing here? Well, this is interesting because it actually, as we can see, two observations were removed from this, right? And those will give you the numbers like 20 and what's the other one? 42. But regardless, so they're taking out a couple of outliers, giving them a 0 weight. Then there's a remaining 46. See, 48, they take 2 out because they think that those two aren't representative. Obviously, one is here and there'll be another, somewhere else. So this is very, very important because now the results change from robust regression. So here you see in robust regression, right, we have a significance between second and first, because without this outlier up here, it's just down here, which is making it statistically significant, right? Before with the LM, this one outlier was driving it up. So that's why this was not significant. And you see down here, it's negative because it's lower, 0.988, which is essentially 1. And then you go down here and it's all of a sudden, wow, that's a really good t-value, 2.3, 2.283. We rounded off to the highest 2.3. So that's pretty good, right? So that all of a sudden becomes significant. And the decrease, because remember, it's negative. This is lower than this one. That's why it's negative. And obviously this third one is very significant relative to the first. So then you go up and it says 0.16. In the normal one, it was just 0.07, significantly different. So the higher the estimate, right, in this case, negative, the better. And the higher the t-value, the lower the p-value. So this is not statistically significant in this model without robust regression, the regular LM, and it is here. So that's important to understand, that outliers matter in these models. And a lot of students ask really inquisitive questions. One is just, I've gotten both sides. One, well, if this point exists, shouldn't it just be factored in because they exist, these outliers? That's a good point. And we want to see different results from different models. So one, we do want to see it with the regular LM with the outliers, but we also want to see what happens when we remove outliers or at least decrease their influence. And then another student said the opposite. He goes, well, why don't we just always do robust regression opposed to the regular LM regression, the OLS regression, ordinary least squares? And I said to him, well, if we just do robust, we'll do exactly what that first student said, just removing, which could be important data points. So for me, you have to actually do both. So when we get to the research on war, we're going to run LM and robust regression to see our results. So again, to recap, the LM, ordinary least squares, that's what it's called, is essentially incorporating all the data points as is. Robust regression, using this Robustbase package, which is LM Rob, it's regular LM, but with robust Rob, that's the function. And then just the regular input. Make your argument, poor mice, and then summary, poor mice, robust, sorry. And then we're getting different results for this one. Now, I didn't really look at the third too much. I don't know. That one, see, that one's still really statistically significant. 4.6. Oh, it did go down 4.3. So there might be something going on here. But regardless, the point is the results changed. They're comparing the second and third to the first. So now it's saying the second is is significant relative to the first, and it was not earlier with just the LM function. And we have to do different models to kind of see. So that's what we've been doing. So are these different poisons, let's say, for example, if we're doing research in chemical warfare, are they significantly different? We could come to the conclusion with robust, they are. With regular OLS, LM regression, they are not. And then robust gives you a ton of interesting information here. If you have big data sets, I ran it on the Trump tweets, remember? That's like thousands and thousands of pieces of data. So tens of thousands. So, this is huge coming out. But regardless, do these outlier matters or not, I would do both models. Take care, everyone.